It seems like astronomers believe it's the beginning to the end of the universe as they continue to look at the mystery of dark energy. They believe that the universe isn't just expanding, but it's accelerating. For almost a century, astronomers have known that the universe is expanding. Space-time is stretching itself out over billions of light years, carrying the galaxies within it apart like raisins embedded within a rising loaf of bread. This steady expansion, pitted against the cosmos' urge to collapse under its own gravity, means that there are two main scenarios for how the universe will eventually end. These scenarios have been called the Big Crunch, where gravity overcomes expansion, and the Big Bang occurs in reverse, and the Big Freeze, which is where gravity loses out to the expansion and all matter is isolated by unfathomable distances. For a while, researchers believed that the universe's fate was leaning towards the final scenario. But in the late 1990s, astronomers discovered something unexpected that changed our understanding of the future of the universe. The most distant galaxies weren't just moving away from us, they were accelerating. This phenomenon has been called the cosmological puzzle. It was independently discovered by two teams of astronomers who were measuring distant supernovae to calculate the precise rate at which the universe was expanding. Expecting to find it slowing down, three of these scientists shared the 2011 Nobel Prize in Physics for their discovery of the expansion of the universe. The award-winning observations came from a survey of distant type Ia supernovae. Astronomers believe these explosions were triggered when a white dwarf, which is the dense remnant of a sun-like star, accretes matter that pushes it over a physical mass limit. That specific limit is the same for all white dwarfs, making all type Ia supernovae the same true brightness. This property made these supernovae ideal standard distance markers, or standard candles, in the mid-1990s. Two teams were actually looking back into time for the onset of cosmic deceleration. They were looking for the point in time at which gravity gained the upper hand over the cosmos' rapid acceleration after the Big Bang. This moment would mark a turnaround, as gravity finally started to slow the rate at which galaxies and clusters of galaxies are pulled away from one another by the expansion of the universe. Since scientists know the true brightness of the standard candles, they could anticipate how bright these distant supernovae would be if expansion was slowing them down. But instead, they found the observed type Ia supernovae were 25% fainter than expected, proving that the universe's 25% expansion isn't slowing down, but instead it is accelerating. By the end of 1998, both of these teams had submitted research papers detailing their discoveries. Of course, the conclusion of both teams was that a large percent of the universe is made up of something previously undiscovered and unexpected, and this so-called dark energy is overpowering gravity and pushing space-time apart from within. The composition of the universe is surprisingly tricky to pin down and understand. Besides dark energy, space is also filled with an invisible form of matter known as dark matter. Astronomers now know that normal visible matter makes up just 5% of the universe, while enigmatic dark matter and dark energy constitute 26% and 69%, respectively. So astronomers don't really understand what about 95% of the universe is really made of. And even decades after their discoveries, scientists still know shockingly little about the dark forces that rule our universe. Understanding and measuring dark matter and dark energy is difficult. Imagine bumping around in a dark room, occasionally touching an elephant, having never seen one and trying to understand what it is and what it looks like. But the dark room is the same size of the universe, and instead of touching the elephant, astronomers can only see the effects that it has on objects. Astronomers can see the dark matter gravitationally interacting with visible matter, so they suspect it could be made up of one or more unknown particles. Dark energy could be a fifth fundamental force of the universe. The known four elements of the universe are the weak force, the strong force, gravity, and electromagnetism. But its exact properties are still a mystery, especially since dark energy seems to have randomly turned itself on. It was also said that the most recent measurements show that dark energy really kicked off its acceleration about 5 billion to 6 billion years ago, and it's been the dominant force ever since. The simplest explanation for dark energy is that it is the intrinsic energy of space itself. Einstein initially introduced such a concept to allow for a flat universe when laying out his theory of relativity. Einstein's so-called cosmological constant is a repulsive force that counteracts the attractive force of gravity to allow for a universe that neither collapses nor expands. But in the end, Einstein dismissed this concept after Hubble observed the universe expanding. The Nobel-winning supernovae research work in the 1990s resurrected the cosmological constant and related it to dark energy. In the future, they hope to ultimately resolve this dark energy puzzle by doing more measurements. The world's best theoretical physicists have tried to work out a grand unified theory of physics that fully explains all aspects of the universe, but so far, gravity and quantum physics don't seem to mesh, despite the fact that theorists believe their unification is essential to any theory that will also explain dark energy. The contribution of dark energy grows as the universe ages. The universe will expand progressively faster over time. Other galaxies beyond our local group, which will have merged with a single giant galaxy called Milky will eventually be whisked out to such great distances that any far future occupants of our solar system wouldn't be able to view them. Like, comment, share, and subscribe. Thanks for watching. Goodbye.